Hey, welcome back to Parametric House, and in this Grasshopper tutorial we want to make this parametric pattern on a closed curve or an open curve, and then control some of the parameters, for example the division, number of divisions of this pattern on a curve. How can we change it with the distribution of the rotation, like this with a Graphmapper, and the minimum and the maximum of rotation we want on the elements, which I'm going to explain in this tutorial. Also, there will be some parameters which will define the geometry. For example, I can change the distance from the curve. You can see by changing this one, the length of these lines we will explain further, and also the rotation. You can see that I can rotate them inwards and outwards like this, and also the length. So this is the multiplication of the length. Maybe we can just change this angle and open up like this. So we're going to explain and talk about that. We're also going to use the Fatten tool to give this a thickness, which is going to be controlled by a series of radiuses. And at the end, we're going to use the Remap plugin to smooth the mesh and get the final results. Let's just take a look at this in Rhino, and you will have this in Rhino. So you can bake that in Rhino and get the final results. Okay, first of all, let's go and start this from scratch. But before we get started, if you're new to our channel, welcome. Consider subscribing because we have weekly tutorials on Grasshopper. And also, if you want to learn Grasshopper from the beginning and you're new to our channel, you can watch up this tutorial up here, which is why you should learn it, and some basics of Grasshopper. We also have a course called paracourse.com. You can check that out if you want to also have extra lessons and extra example files in Grasshopper. Okay, let's get started first by defining a curve. I'm going to use two sets of curves. One is a closed curve, for example this circle, and another one just this open curve like this. Okay, so I can explain the basics part of the lessons. I'm going to bring this inside. Let me just put the bifocals plugin. Okay, we're going to go to the params menu and pick a curve. Let's just Control C V that and set this one to a closed curve and to an open curve. Okay, to make it easy, I'm going to start with an open curve and then we're going to fix it for a closed curve. Okay, so let's just get rid of this and turn it off and go forward with this simple open curve, which we can control in Rhino. Change the control points and update the curve. Okay, before we go to the pattern, let me explain what we're going to do in Grasshopper. First of all, assume that this is the base curve. Okay, we're going to extract the perpendicular frames. So we're going to use perpendicular frames to extract it. If you don't know about this one, we have a short lesson about perpendicular frames. I'm going to put up here in YouTube so you can check it out. Okay, then what we want to do is so we divide the curve into perpendicular frames. Then each of these frames, for example this is one of those frames, we're going to use a range to rotate it. Okay, so we're going to rotate it around the z-axis, and this will give us a base plate. For example, let's assume that this is a rotated plane here. Okay, this is the location. So this is going to be, for example, an X and a Y. Let's do that in Grasshopper, then I'm going to explain why I am doing this. This can be a good exercise to learn about perpendicular frames again. So I'm going to go to the curve and use this division perpendicular frames. And let's just give this a division. Change the size of this displaying the planes by going to the display and preview plane size. And change that to maybe 10 so you can see the planes. Okay, and the division maybe from 3 to 30. And if you delete the title of the number slider and connect it, it's going to get the name of the input, so it's going to be the count. Okay, so this is the perpendicular frames. Now that we have this perpendicular frames, we want to rotate it. The best way you can rotate these are using the rotate plane, okay? So it's going to rotate a plane from the z-axis, so it's easier to rotate it. You can also find it in vector, and in the plane section, here it is, rotating the plane. We're going to give that plane to the plane. This is the frames or the planes we want. And automatically it's going to rotate it around the z-axis and the center. So let's just give this a degrees. For example, if I give this a 1 number slider, it's going to rotate it. You can see that you can rotate all of those planes with a single degree, but that's not what we want to do. We want to give this a range of controllable range of rotation. We have talked about range and series. If you want to know more, you can check out the I guess that it's a Graphmapper tutorial, so you can check that out if you want to get more about it, but I'm going to explain it step by step here. First of all, we're going to use the range tool. You can also find it in the sets here in the sequence, and we have the range. We usually use the range and series for making a series of number. The series is going to be a step-by-step. A range is going to be from minimum to maximum. So we can control the minimum and the maximum of rotation of the pattern. To make the domain, I'm going to put it from 0 to 1. Why? Because we're going to use a Graphmapper. Okay, so I'm going to use a Graphmapper later on, combined with the range, and the Graphmapper usually starts from 0 to 1. Okay, so this is a trick you can always use. Combine a range with the default 0 to 1 with a Graphmapper, then we can remap it into a minimum maximum we want. Let's just do that. The steps here is really crucial. If I give that 12 for an open curve, okay, when you divide a curve into this count, let's just go here and give it a panel so you can see. Okay, when I divide this into 12, it's going to give me 13 planes. You can also put the cursor here and see it like this. Here it is, 13 locally defined values. So remember, it's going to add up the count by 1, because if you, for example, divide a curve into 2 segments, right? It's going to be like this, 2 segments, and it's going to have 1, 2, and 3 data. So it's going to add 1 here. Obviously, for the range is also similar. So if you divide a range of number, for example, from 0 to 1, divided into 2, I'm going to make it easy, divided into 2 sections, is going to be 0, 0.5, and 1. So it's going to be 3 numbers. Again, you can see that this is okay. It's 13. This is really important for the closed curve. When we have a closed curve, we have to fix this, which I'm going to explain later. Okay. If I connect that to the angle, it's not really rotating. It's just rotating from 0 to 1, which is really small. Let's just give this a Graphmapper, so we can also find it here in the inputs, in the params menu, and in the input we have this Graphmapper. Okay, and let's just give this a busy distribution. These 2 handles can help you to change the distribution of the rotation. Okay, now we want to make it from maybe from 0 to 90. You can also use that. Let me just give you some hints about this. Maybe you want to use this for a building, so, or a pattern. You want to make it vertical, so you can also make a curve in the height. Let's just do that. Doesn't really matter. Let's just delete this one. And we're going to remap this between minimum and the maximum. So the math, the domain, and here we have the remap numbers. I'm not going to use remap plus. This is the tool we have made, but the remap numbers is the default tool in Grasshopper you will find. You can also find it here, remap numbers in the domain in math. Simply give the Graphmapper to the value. We have talked about this in range and series in the tutorial I'll put up there, but for those who just don't want to check that tutorial out, this is the basic combination: range, Graphmapper, remap. Okay, this is going to give you a controllable range of numbers. The good thing about this one is that the source is from 0 to 1. So this is going to help you when you use this 0 to, okay, let's just make this smaller, 0 to 1 for the domain. It's going to also help you with the Graphmapper, and it's also going to help you with the source. So you just have to give this a target, right? Which is easier instead of defining the domain and then changing this one and then playing with these inputs. So let's just go to the math and construct a domain. So I'm going to construct a domain, and we can give that to the target, and that is going to define, let me just change it so you can understand. It's the minimum rotation and the maximum rotation. So this is going to help us. Maybe we want it from 0 to 360 degrees. And we can give it here. Okay. Now we have to give this to the angle rotation of the planes. Let's make it like 90 degrees. And you can see it's going to, for example, if the X direction here is like here, it's going to end up in that direction, right? It's like rotating 90 degrees, and it's really easy. You can do that. If you don't want this a little bit tilted, remember that this point has to be like perpendicular to this plane. It's going to be harder if you want to do that, or you can just simply go to the front view, draw a polyline which has a vertical start. Okay, and then maybe bring it a little bit up, and then use this, I guess that we have it here, curve control point from polyline, and delete the polyline. So remember, it's like here. And now you can see if I give this as the base curve, it's going to be perpendicular at the XY plane. The reason here is that the control points has some sort of magnitude, so it's going to assure that it's like in the XY plane. It's going to be the same for the end of the curve. Okay. Maybe we can scale this if we want to change the form. Okay, and you can see obviously this is the X, and now it's going to go like that. We can control the minimum and the maximum. Okay. Now let's just go back to the algorithm and check this out. We made the planes. Let me just turn this off and tell you what we're going to do. Okay, these are the planes that are rotating. I guess that I have to make this a little bit bigger so you can see what I'm doing. Okay. First of all, I'm going to deconstruct the plane. Okay. And make a line like this in the X direction. And then I'm going to give some spikes in the second direction. The reason I'm doing this is that when we want to make this a unified mesh, we have to have some space between this. For example, let me just show you here. If we have two set of curves and we make a pattern like this here, and instead we make it like this, what happens is that when it wants to make a mesh, here we'll have some problems because it can't find a direction. But with this one, giving it a little bit of a handle, it's going to also have a good space for making the base curve volume. Okay, so that's the trick we have to use. And then I'm going to explain how we will use that handles like this to make it into degrees. Okay, now let's go back to our example and play with this one. So we have to, that is really easy. Let me just make this into a group. So when you open this example file, you can see that this is really easy. We had a curve, we made the perpendicular frames, and then we rotated it with these steps. And now that we have the plane, let me just put that into a plane so you understand that we are working with the plane. We want to make that handle and lines. I'm going to go to this curve section, use this line SDL, means start, direction, and length. That's why it's called SDL. So we're going to give that to the plane. We need the directions. Okay, now let's just go to the vector, and in the plane we have a deconstruct plane. A deconstruct plane is going to help you to have the center, the x, y, and z vectors. That's the best tool you can use in geometry because it's going to give you lots of information of the plane. Origin, x, y, and z, which is the tangent on the curve. Okay, the origin is going to be here. The direction, I'm going to use the direction one in the x direction and another one in the minus x direction. So we just type NEG or a negative. You can also find it in math, and I guess it's in the operators. You can, okay, let's just open it. It's like this here, negative. So I'm going to give this to the direction, again a negative, and use the shift key. Remember, you have to select the shift key and then give it to the direction. So it's going to use the both of it. Okay, we have some problems here. Let me just give this a length so you can see the lines, and I'm going to explain what's happening here. And you can see we have lots of lines here, but we don't have line here. The reason is that these inputs, it's like 13 origins, and then we have like 26 directions and 1 length. So what's going to happen is that the first start is going to go to the first direction and the first length. Then the second start is going to go, you know, the number is not the same. 13, 26, and 1. So there is a small trick you have to do. Just right click on the plane and graft it. That means that each plane is a group and we are working in each plane. You can see that's going to fix that. And if you don't know about graft, flatten, simplify, and those things, we have talked about this. Let me just put it up here. You can check it out. We have also a complete section for the Power Course users, which we have talked about groups, because obviously a programming language with geometry is a little bit hard to understand, so you have to understand what's happening here. So you have like 13 planes, then you graft it, so each plane becomes a group. So when you use that, you can see that it's going to have 13 groups for the start, 13 groups with 2 inputs, which is 2 directions. So that's the trick we used by grafting the inputs of the plane. Okay, now that we have this, let's just turn off the plane here, and you can see that we have these handles. We can just control that size, so we can say L1 is the first size. Okay, now what I want to do here is to, for example, for this plane, I want to make 2 handles out of this. Okay, so what I want to use here is to say it's the Y direction. You can see it here. It's the Y direction. Okay, so I'm going to use 2 Y directions, and then I'm going to rotate it in the Z direction of the plane. If I rotate it around the Z direction, for example, I rotate this 10 degrees inward, so it's going to go inside, and 10 degrees inwards to here. It's going to have 2 handles inside. Okay, if we have it minus 10, it's going to go outside, so we have to fix that. Let's go here. I'm going to go to the curve, use this point on curve tool, and pick up the start and the end. actually we don't need the start, we just need the end, right? And now we have to find the direction. If I give another STL here, for example, start, the direction is like Y. Bring this a little bit up. And then just give the same length to show you. You can see it's all going in the Y direction, right? But we want to rotate it. So what can we do? We can do two things. One is to rotate the direction or rotate the line. You can rotate the line after you just drawn it, and after we have the line basically in the memory, we can rotate it, or you can just rotate the direction. I think that the direction is easier because it's going to make it faster. So what I want to do is to use another tool so you can learn the rotate vector. So remember that we have the rotate plane and now we have the rotate vector. The rotate vector is really going to help you. You have the vector, and in the vector menu you have this rotate tool. So I'm going to just say ROT, find it. Now we want to play with the y-axis, right? In the y-axis. The y-axis is going to rotate around another axis. Remember that we have this y and we wanted to rotate it around the z of this plane, right? So I'm going to give this axis to the z. We are actually using all of these axes, and now again we need a degrees here. Let's just give this 0 to 90 degrees, for example, and give this to the direction. Okay, we have to fix something here, and you can see that it's going to rotate it, but both of those two lines are going to rotate in one direction. So how can we fix this, right? We have to have two directions or 2 degrees. If I give a negative here, add this up, you can see it's going to help, because we want to say, okay, rotate those 40 and minus 40 degrees. So that's the degree. That's the easiest way you can do that. And now because we want to put it inwards and outwards, we have to go from minus 90 degrees to 90 degrees. And we can turn everything off, even the plane, and just see the lines. That is how we can play with this L1 and another one for the L2, because we want to control the second one. So it's going to say L2, right? Maybe we want to control this one. Based on the project, maybe we just want to make this a little bit bigger and control the size and play with that, okay? Or you can just draw a curve on the ground. Doesn't really matter. We want to have an exercise on how Grasshopper can control things like this. Okay. Now that we have these lines here, we just have to also add another line, which is the connection between these 2 points. Because when we want to make a mesh, you have to have lines, not a curve. That's really easy. What you have to do is to play with the curve. I'm going to go to the curve, use this divide curve, and give it the same count. Obviously, when you divide it like 12, it's going to give 13 frames. If you divide a curve by 12, it's going to give 13 points. And now I'm going to just select and connect them by a polyline. Just a polyline. You can see that's going to connect them by a polyline. So that's exactly what we need. It's like a centipede. Okay, and now that we have this polyline, and also I'm going to use another to put up this curve and this curve with a shift key. I'm going to flatten all of them. Again, you can put a curve and put it all inside a one parameter and flatten it, so we have all of these lines. Okay, that's the base of the pattern we needed, and now we can just give it a volume by using the Fatten plugin. You can find it in the mesh. You have to install it in File, Special folder, Components folder, restart your Rhino Grasshopper, and you will have this Fatten tool or plugin. And we're going to give that to the skeleton. You can see it's going to make, let me just hit Control M so you can see the meshes. Okay. We have to give this a thickness, maybe from 1 to 5 with 2 decimals. You can just type 1, 2.5 with 2 decimals. Okay. This is going to be the thickness that we want to play with this. You can also change the thickness at the vertices, and that is the spheres. You can see that you have to define a series of spheres as a list on the knots. I'm going to use a great component called curve and use this deconstruct explode in the utility. Explode a curve. Or maybe, why should I do that? We have the points here, the division. Let me just put that into a point and bring it at the end. That's easier. Okay. Now what? Why did I do that? Because I want to give a sphere from surface sphere, just to show you what's going to happen. This is the thickness. Let's just increase that a little bit. The thickness at the vertices. So if I give this spheres to the spheres, you can see that actually we are also controlling the knots. If you decrease, it's going to change, but the combination of this thickness and the spheres is going to overall change the project. Okay, just play with these two numbers, or just delete this sphere and play with the thickness. It's based on your project. You can see that we can control it with the spheres and give it exactly this thickness. So that's the trick. And let's just increase the length here. We have some more offset, and let's just deform this a little bit like this, so you can see the results. Maybe just, we don't want the rotation, so I'm going to put it to 0 and just play with the length, the degrees we want to rotate, and the second length, like that. Okay. The last thing we want to control here, so remember that you can also play with this radiuses and thickness. Basically this has to be smaller, I guess, so it can affect it. Combine is not going to affect this. Okay, the last thing we want to control is the end type. You can see we have 4 kind: open, pinched, capped, and spikes, 0 to 3. I'm going to give this a number slider from 0 to 3 and give it to the end type: open, like that, flat, and spike. Maybe a spike is going to be a good one. If I bake this mesh, you can see that we have a good mesh here, completely good. Even for 3D printing, it's not going to have any problems. So what I want to do is to give it a little bit smooth, a smooth look. So why not just go to the Weaverbird plugin and use this Catmull-Clark subdivision. Okay, I just want to show you the name. In the sub-D, I usually use this one in the Weaverbird plugin. Again, you have to install it in the File, Special folder, Component folder, and then you will be able to smooth your mesh. And remember, the maximum level is going to be 3. So I'm going to give it like 3. And just delete the title so you can see it's like that. Okay, we can just turn everything off. And we can hit Control M so you don't see the mesh edges, and you can also connect a display custom preview, give it a swatch to have a fast overview, see the results. Okay, it's like that. That's it. Remember that you can play with these, and the thickness is really based on the spheres I'm going to define here, like that. Remember that we can play with the second length. Maybe just a little bit open, and put it down inwards or outwards. You can see even we can go more by saying like minus 180 to 180, because we didn't rotate the parts, so we can just play with this one. Remember, but when we rotate it, the minimum and the maximum is going to affect the form. It's going to be like 90 degrees. We can define the distribution of the rotation. This is a good exercise so you understand the rotation. We have talked about this before. Maybe we can increase the radius a little bit, and the thickness. It's going to give you more freedom for the form. And if you don't want the spheres, just disconnect that and play it with a thickness. So remember that you can always connect the sphere to here. I'm going to put this here so you can understand that. You can also do that. Okay, that's it. That's the tutorial of how you can make that weird 3D pattern. But if you want to make this on a closed curve, what if I wanted to make this on a circle? How is it going to help me to work on a closed one? Because we don't have the closed connection, we have an extra polyline here. How can we fix this? This is going to be easy. Let me just right click here and extract the curve. We first need to work on the curve to see if it's closed or not. So I'm going to just type closed, and you can find this. Is it closed or not? You can find it in the curve menu, analyzes, and here it is. Is it a closed curve or not? So if I give it here, you can see it says true. So we have to do two things. One of them is the polyline here. You can see that it's connecting the polyline. Let me just turn this off. But it's not connecting the start to the end. So we have an option here, closed or not. I'm going to just give this to here. So that's going to give it an end. So we will have a connection at the end, right? Like this. Problem we will have here is that it has two polylines there. Okay, so how can we fix that? The reason here is that when we divide a curve, a closed curve, into a count, for example 12, it's going to give us 12 divisions, not 13. It's going to give us 12 frames, and the problem here is the range. The range is not a geometric tool, okay? It's a number tool. So it doesn't understand it's a close or open, and it has an extra one here. So I'm going to use a trick here and give an integer to the closed curve. You can just find it in the primitive menu. And when it's a true or a false, it's going to be a 1 or 0. So how is this is going to help us? I can just bring it here near the range and say whatever the count is minus this. This is the technique you can use. Minus this with the number and then give it to the steps, right? So if it's closed, it's going to minus this with 1, and if it's not closed, it's going to minus this with 0, which is actually a normal algorithm. And you can see it's completely working. If we wanted to put that to 0, it's a complete closed curve. We can increase the thickness. Remember that. We can change the end type if we want to. We can play with this degrees thing. And we can also change with the length if I want. Okay, that's it. Maybe we just want to rotate this, but I guess that 180 degrees is better because it's going to have a seamless rotation, right? And maybe increase the number of the patterns. Maybe it's a ring or something like that. Okay, I guess that this is a good exercise and tutorial for learning Grasshopper if you want to learn more advanced lessons. But I just want to give you another hint, which is giving this an animation. What if I wanted to make this an animation and going like this, just rotate it around and around. This is going to be cool if you have a closed curve and look at it from top. Let's increase that number and give it a more radius or thickness. Maybe we have to play with this one. And you can see it can give you a good sense of animation. You can see these are rotating. We can play with the angle to get 0. It's not good. It's going to be 90 degrees. The length. You can see it's going to give you a good sense of, maybe you can use that for art or something, animation. How can we do that? It's really easy. You just have to make a timer to add it up to the degrees of rotation. So how can we do that? It's really easy. First of all, let's go to here. Okay, turn this on. We have it like here. Now we just want to give it a rotation. I'm going to internalize this so you can have this in your project. If you want to download this example file, you can go to our website parametrichouse.com and get the example file. Okay, so how can we simply just give this a timer? This is the degree, right? And it goes to the rotation. So what I want to do here is to add this with a number which is going to change by time and then give it to the angle. Right? So it has to change by time. We can go to the params menu, utility, and use these two tools. One is a data recorder, and another one is, let me just put that up, data recorder, we always use that. And also we need a timer. I guess that's, you can find it, it's called trigger. It has changed the names to trigger, it has a timer before. So it's called trigger. Before in Rhino 6, I guess it was timer. So we have to learn the new names. It's a trigger. Okay, so these two tools we have to use. So what we're going to do is to say, first we have a number slider, 1 to 10, or 1 to 30 maybe. This is the speed, because we have to rack up these number on each other. So it's like, for example, if it's a 10, it's going to be like 10, 20, 30, and the rotation is going to be faster. And if I give it a 1, it's going to be 1 degrees, 2 degrees, right? So this is going to be actually the speed. What I want to do here is to record this. And when you want to record it, you have to connect a timer so it updates it, right? Right click here and select the interval. And it's going to be maybe 10 milliseconds, right? Okay, you can see it's going to just record all of those numbers. So why do we need that? We just simply can add them up by going to the math and using this mass addition. This is how you can make a timer in Grasshopper by using these tools: a trigger, a data recorder, and a mass addition. Let me just put the panel here so you can see. Here it goes. So we can just pause it. I guess that we can even reset that by clicking here, and then we can change the speed, how fast it goes, right? And we are good to go. We just have to add that to the rotation. So we have a timer, and that's it. That's how you can make a timer. This is going to be the speed. Make it slower, make it faster. Pause it if you want to, and run it and make a reset. That's it. So I'm going to pause this. If you want to, you can also use this timer thing, a great tool to add up things here. So that's it. That's really not that complicated. I hope that you learned from it. It has some good techniques. Maybe in the future you can use it in your projects. Okay, thanks for watching, and remember to subscribe to our channel, like this video, because if you like it, it's going to perform better. Thanks for watching. See you next time. Bye.